Hi ladies. So we're moving on to thermochemistry. So this is kind of the last part of the chapter that we were doing, which was fuels and thermochemistry. Okay. So there's a little bit of maths to this bit here. So I'm going to talk to you some of the definitions. I'm going to show you how the questions are sometimes phrased, and then I'll post up another video on how to do the 3 questions at the end of this. Okay. Okay, so girls, today you need to be able to recognise what an exo and endothermic reaction is, understand what the heat of a reaction is, understand what the heat of combustion is, know what the heat of formation and neutralisation are, and know and understand Hess's law and be able to use it in a mathematical sense. Okay, so this is mostly definitions. So girls, thermochemistry is the study of heat changes that occur during chemical reactions. Now, exothermic reactions, girls, are ones that give out heat. So you'll be most familiar probably with combustion and also heat pads. You know, when you break open one of the little heat pads that you can get for a sore back or whatever. So that both of those are exothermic reactions. Also, if you add an acid and base together, you get an exothermic reaction too. It can feel it heating up in your hands. Or if you add magnesium to acid or anything, or calcium to acid, you'll get a quite strong exothermic reaction and you'll be able to feel heat given off. Okay, so any reaction that gives out chemical heat or gives out physical heat, then that means it's exothermic. Endothermic is the opposite. It's where reactions take in heat and they feel cold to the touch. So example, this will be kind of these dip dabs, you know, the sherbet stuff that goes in your mouth and gets colder. Or sometimes if you get like, you know, the blue extra as well, that will have an exothermic reaction in your mouth that feels like it cools it down. And also the cool packs that you get if you're spraying something, they're all endothermic reactions. Now, girls, so heat of reaction, girls, is the heat change that occurs when a reaction has gone to completion. It is represented as delta H. So delta H just means literally change in temperature. Okay, if your delta H is negative, that means that it's an exothermic reaction. There has been heat given out. If your delta H is positive, then that means that it's an endothermic reaction. I remember this because remember, to burn yourself is a negative thing. So if there's heat given out, it's a negative thing. So delta H is negative for an exothermic reaction. Okay. Now, in thermochemical equations, girls, that you'll notice that the states are always given of the reactants and products. That means you're told whether something's a solid, liquid, or a gas. Okay, so you'll see these little brackets with G's and S's, and AQ is aqueous solution. Okay, so don't be frightened of these little brackets, just telling you whether it's a solid, liquid, or a gas. It's important. Equations will be balanced, and your delta H is always written. Okay. The heat of combustion is a type of heat of reaction. It is a heat change that when 1 mole of substance is completely burnt in extra oxygen. So again, that's one of your first definitions you need to know is heat of combustion. It'll always be negative because all combustions are exothermic. This is just for your own information. So if something isn't completely burnt, it is no longer the heat of combustion. It will be the heat of reaction. Okay, so just be aware of that. That can happen sometimes with some carbon-containing compounds. If oxygen is a limiting factor, so if there's not enough oxygen there, you won't get a full product being burnt. Okay, so you might get carbon monoxide and carbon dioxide instead of carbon dioxide. So that will be heat of reaction rather than heat of combustion. So heat of combustion has to be, the material has to be fully burnt. Also be aware, girls, for many of these definitions, we are talking about for 1 mole only. So here we've got the burning of butane, okay? So butane is burnt. This is the balanced equation. However, when you get your delta H being minus 5,720 kilojoules per mole, you need to be aware that this is for 2 moles of butane being burnt. So the heat of combustion must be half of this. Okay, so if this is the heat change that occurs when 2 moles are burnt, then to work out the heat of combustion of butane, we're going to have to divide this answer by 2 to actually get the heat of combustion of butane. So just always be aware that for a lot of these heats of reactions, girls, it has to be only 1 mole being burnt or being formed. This is what's called a bomb calorimeter, girls. You won't see one of these in the labs because they're too expensive. We use something a lot less high tech, all right? So essentially it's just a metal insulated container where we do certain reactions and we measure the heat change that's transferred to the water. So a bomb calorimeter is what we do thermochemical experiments in. Now, when we're talking about a mole of something, girls, okay, it's not really practical. Practical to do reactions at 1 mole scale when you're in a proper industrial lab. So often, what they will do is they will do the heat of formation of 1 kilogram or the heat of combustion of 1 kilogram of material. So a much larger amount because it's much easier to handle. So just be aware that's called the kilogram calorific value rather than the heat of formation or heat of combustion. Okay. Delta H and bond energy here then. Okay. Now, delta H and bond energy. So bond energy is the energy required to break 1 mole of covalent bonds and separate the neutral atoms completely from each other. Okay, now I'm going to show you a number of examples of how to do these now a little bit later on. Okay, so what you're provided, what you're provided with is the amount of energy required to break or form molecules, and then you have to use that information then to find out the heat of formation. So I will show you how to do these. They're very easy. They're not too hard. For this, girls, though, you have to remember that to make a bond gives out energy, to break a bond takes energy. So what are neutralization reactions? Neutralization reactions are reactions where an acid and a base, 1 mole of acid and 1 mole of base, come together and react together. And they are always exothermic. Okay, so again, another definition you need to learn. When we're doing this in the lab, girls, we don't have a bomb calorimeter. We have a polystyrene cup with a thermometer in it, and we mix together an acid and base, and we do our reaction there. So that's one of our mandatory practicals. Now, the heat of formation, girls, another definition that unfortunately you need to know is the amount of heat change that takes place when 1 mole of a compound is in its standard state is formed from its elements in their standard state. So again, you have to only form 1 element, 1 molecule of the material. Okay, so it's all about 1 mole. We can calculate the heat of formation due to the discovery of scientist called Germain Henry Hess. Okay, so this is Hess's law. Now, Hess's law, girls, states that if a chemical reaction takes place in a number of steps, the sum of the energy changes of those steps is equal to the heat change of the overall reaction. Now, this is not as scary as it sounds. I'm going to do a number of Hess's law maths questions for you, so you'll see that it's actually quite easy, okay? So this is just demonstrates here that even if you have something happening over a number of different steps, it should add up to the heat change that occurs, even if it occurs in 1 step. So the questions that I'm going to attempt next class are this one, so you can pause it and have a look, this one, and this one. Okay, so I'm going to do a number of different questions on a little mini whiteboard so you get an idea of how to do these styles of questions, but they're not too hard. The hardest bit is learning off your definitions. Okay, thanks, girls. This is Alana. Say hello. Say hello to everybody.
Hello.